Hello, Darren here, and today we'll be looking at exponential and logarithmic functions. And the reason I'm putting these two in one video is because they have a very close relationship to one another. So what is that relationship? Well, they are inverses of each other. What does that mean to be inverses? Well, we can look at the meaning mathematically and also graphically. So mathematically here we have an exponential graph, y equals e to the x. And let's apply our normal procedure for finding the inverse of a function. So swap x and y for inverse is a very important step that you need to state in your working out. So then we have x equals e to the power of y. And of course the opposite, or to sort of get rid of something to the power of something, you log that. So log e of x equals y. And hence we see that an exponential function is the inverse of a logarithmic function, and vice versa. What does this mean graphically? Well, since we're swapping x and y to find the inverse, graphically it means that the graphs are reflections of each other over the line y equals x. So you're probably used to reflections across the y-axis or across the x-axis. You can really reflect across anything, and for inverses, that reflection happens to be across the line y equals x. Now let's have a look at an exponential function, y equals e to the power of x. There are a couple of things to note here. Firstly, e to the power of x has to be always greater than 0. Let's talk about why that is. E, remember, is just a positive number, sort of like pi. It's not a pronumeral like a or b, but it's a positive number. And when you take a positive number to the power of something, or in other words, multiply it by itself some number of times, you can only get another positive number because you're just multiplying positive numbers by themselves. And so e to the x has to be greater than 0. And that means that there is an asymptote at y equals 0. Now let's have a think about what the graph looks like. We know that there's an asymptote, but where does this graph lie and what does it look like? So it's always useful to consider what happens to the graph as x changes. And the most obvious rule here is that as x becomes bigger, e to the x becomes bigger as well. Now this is because you are multiplying e by itself more times, which makes sense to be bigger, and the increase would be quite sharp as well. For example, look at 2 to the power of 2. The difference between 2 to the power of 2 and 2 to the power of 3, so the difference between 4 and 8 is only 4. And the difference between 2 to the power of 6 and 2 to the power of 7, so the difference between 64 and 128 is 64, which is a much larger number. So the increase becomes sharper even when x increases by the same increment. Now this rule is also true if x is a negative number, and think about why that is. Something to help you out is, as we talked about in power functions, e to the power of negative 2 is the same as 1 divided by e to the power of 2. Now putting all that together, we have the asymptote at y equals 0 and the graph of y equals e to the power of x. Next, let's have a look at y equals log e of x. I will draw it on the same axes just to show you guys. Keep in mind that the two graphs are inverses of each other, and I will draw y equals log e of x on the same axes to illustrate this relationship. So there is an asymptote at x equals 0 for the graph of y equals log e of x. There are two ways to think about this. Firstly, since we are reflecting the graph of e to the power of x over the line y equals x, therefore the asymptote at y equals 0 is reflected to become the asymptote at x equals 0. Also, mathematically, you can't have log of a negative number. The reason for that is if we slightly rearrange the equation, you have e to the power of y equals x, and you see that x can't be negative because e is a positive number, and you can't take a positive number to any power to receive a negative number. The key point to note with log e of x is the x-intercept, which is 1, 0, because log of 1 is 0. Now if you consider x between 0 and 1, you have a negative number. Now the reason for this is that any fraction between 0 and 1 can be written as a fraction or integer bigger than 1 to a negative power. And you should know by log rules that the negative power goes at the front. So for example, if x equals a half, we are saying log e of 2 to the negative 1. The negative 1 goes to the front, so essentially we have negative log e of 2. And log e of 2 is a positive number, so you have a negative number. And for x greater than 1, log e of x is a positive number. So let's draw the graph in. As you can see, if we draw in the line y equals x, the two graphs are reflections of each other across that line y equals x. and it's important to note that they intersect on that line as well. Good luck with your studies.